you can interrupt me and say that to me, so it's okay.
Okay.
So, I'm very happy to be here. Even I would like to be in Kenya directly, but unfortunately, due to COVID-19, I can't. But I'm very happy because I'm very happy to participate in your meetup, and I'm very glad that I will talk for a topic that it is a little unusual for a front-end developer. So today we're going to talk about how to create a desktop application using web app technologies. And when we say web technologies. And when we say web technologies, we mean HTML, CSS, and JavaScript. So particularly, we are going to talk about how to build an Angular application and integrate it with the Electron JS framework that we use it for creating desktop applications using web technologies. So let me tell you some things about me. This is me. I organize an Angular meetup like yours here in Greece. I'm from Greece. And the meetup is called Angular Athens because Athens is the capital of Greece. I work as a front-end web developer at a company called Plex-Earth, and I'm specialized in the Angular development. So my everyday life as a developer in the company is writing Angular all along. Also, I work as a contractor in a private institute, which is called Code Hub, and we teach Angular framework to other developers and individuals. When I'm not coding, I maintain a personal blog at Medium, where I mostly write about Angular. And in the last 6 months ago, I started to write my own book about Angular, which was published earlier this month, and it is called Learning Angular 10. If anyone is interested, it is available for pre-ordering in the links that you saw on the right-hand side of your screen. It is actually a book for beginners, and it walks you through creating an Angular 10 application from scratch by scaffolding the application using the Angular CLI and up to deployment to a hosting provider. I'm also an active contributor at GitHub, where I love to help other developers. My main areas that I focus are Angular-based repositories and libraries, like Angular.io, where I often contribute to the official documentation. And also another area that I'm interested is 3D maps and geospatial libraries, such as Cesium that you see on your left-hand side of the screen. Cesium is a popular JavaScript library for creating 3D maps. In my personal GitHub account, I have created a proof of concept application that integrates Angular with Angular material. It showcases how to connect them together and create an Angular application using the Marvel API. So if you're a fan of superheroes or you generally want to test something with a real backend API, you can try this. So as I told you, I work as a front-end web developer at a company called Plex-Earth. Plex-Earth is actually a product which has been developed by a company called Plexscape. So Plex-Earth is a product and Plexscape is a company. It is the first desktop cloud-based software that was created ever for the engineering and the construction industry. It works with many CAD software, and when we say CAD, we mean software that civil engineers and architects use to create 3D models, buildings, and stuff like that. So it enables civil engineers and architects to visualize their 3D models and their projects in the real world of Plex-Earth, Google Earth or another map provider. Most of our customers exist in the USA and the Canada territory, about 92 to 93%, and some of them are the circuit team of Formula One, Ecom, Garver, and here in Greece there is a company called Hellenic Petroleum, which is a very large company. So in this image on the top you can see Plex-Earth, which actually Plex-Earth is a plugin of this CAD software that I'm talking about. One of the most known CAD software is AutoCAD. I think many of you would have heard of it. So here in this image we can see Plex-Earth, which runs inside AutoCAD, and you can see that there is a ribbon on the top that displays some commands and actions that Plex-Earth can do. So the main features of Plex-Earth are three. The first one is that you can import imagery, and when we say imagery, we mean satellite images from map providers. The second one is that you can use, again, map providers to import terrain. And the third one is that a civil engineer or an architect can export a 3D model or a 3D object, for example, a building, to Google Earth. Today we're going to focus on the first one, which is import imagery. So Plex-Earth has three ways to import imagery. The first one is using some core map providers, such as Digital Globe or Hexagon. They usually have their own satellites or small planes that fly around the globe, and they can take their own images. The second one is using an intermediate mapping provider, such as Google Maps or Bing Maps. These intermediate providers usually, not always, usually they don't have their own satellites, they don't have their own way to grab satellite images, but they use the providers above. And the third one is Map Explorer. Map Explorer is an application, a software that has been developed by our team at Plex-Earth, and it allows you to create custom maps from all the above providers. It's a proprietary software that we have developed in-house. So at this point, I would like to explain to you a bit about how we think about a map. So suppose that you want to create a map that displays all the countries of Africa, for example, with their borders and a different background color to each country. So what would you do? You would use three different layers to create a map. A map consists of different layers. Okay, so to compose such a map, we would use three layers. On the bottom of the layers, on the first layer, which is also the base map that we call it, we would put a layer that covers all the world. Or, for example, Google Maps, Bing Maps, or OpenStreetMaps. Okay, a layer that displays all the world. Above this, we would put another layer which would display only the borders of each country. And above this one, we would put another layer that displays all different colors for each country, but only in these locations, not all the world. So you can think of a map like when we have slides and we want to project something, we want to show something in a projector, and we overlay one slide over another. This is how a map actually is created in the GIS world, in the geospatial world. So at this point, I would like to show you a video where it showcases how Map Explorer uses, how Plex-Earth uses Map Explorer to import images. So let me. Okay. Now here we can see we are in the environment of AutoCAD and we open Map Explorer. Let me lower the speed because it's very quick. Okay. So here is Map Explorer. There is already a base map for us. So we create another layer on top of our base map, which is called ESRI. It is a very well-known map provider. So if we create it, you see that it goes over the base layer and it covers it all. So above this, we will create another layer that we give it a name. Sorry for the name, it's in Greek. Sorry about that, but I can translate you that it says railway network. So we are going to display a map, the railway network of a country on top of a map. So here we select the layer. We save it. Here you can see the blue lines are our railway network. It is the layer that we would like to display after all. We can also toggle the visibility of each layer so that we can get a better understanding of our map. And if we close Map Explorer now and we return to AutoCAD, we select the area that we want to import this map that we created. So now Plex-Earth downloads the images of the map that we created, and it will add it inside our AutoCAD project. And here it is. So Plex-Earth uses Map Explorer to import imagery into AutoCAD. But what is Map Explorer actually? Map Explorer is built with Angular and Electron. So what you saw in the video, the little window with the map, it was built with Angular and Electron. Nothing so special. So I think most of you that you watch know about Angular. I mean, we're in an Angular meetup. Isn't that right? So let me tell you about Electron. What is Electron? It is a cross-platform JavaScript framework that allows us to create desktop applications using HTML, CSS, and JavaScript. So it gives the opportunity to web developers to leverage their existing web skills and create desktop applications without the need to learn a new desktop language, for example, C++ or C#. It is built on top of Chromium, Node.js, and V8 engine of Chrome. Actually, an Electron application contains embedded a version of Chromium and Node.js, and that is why most of the Electron applications out in the market are large. Their executable file is very large. For example, you can think that Map Explorer is about 95 megabytes in total size, and our application source code is only 3 megabytes. The remaining 92 megabytes is the executable that is we use to bundle it as a desktop application. So there is a trade-off that we need to pay there. Many popular applications have been built with Electron, such as Visual Studio Code. I think most of you know it and use it. Slack, Skype, and WhatsApp. So let's go to see a bit about the Electron architecture. Electron has two main processes. The main process that is responsible for heavy tasks and calculations, for example, when you want to interact with the file system, and it is this process that provides you access to the native resources of your system using Node.js API methods. The renderer process is responsible for managing the user interface only. So imagine that the render process is able to load a single index.html file that contains your application assets, included your CSS files and your JS files. So the Electron architecture follows the Chromium multi-process architecture. So in an Electron application, we can only have one main process, which can communicate with many renderer processes. But notice that each renderer process operates in its own environment in complete isolation. So one renderer cannot communicate with another one directly, only via the main process. So, Aris, how would we create an Electron application? Let's see some basics. To create the Electron window, for example, you would use JavaScript. Okay, an Electron application is just it's a JavaScript file, or many JavaScript files. But generally, you write it in JavaScript or TypeScript. In the demo at the end, I will show you how it is created, how we write it with TypeScript. So essentially, we use a class called browser window, and we create an instance of this class, and we pass some options, for example, the width and the height of the window. This will create a desktop window, and then we use the load file method of the browser window to pass the HTML file that we want to render inside the window. This code that you see is not all the code that you need for the Electron application, it's just a small snippet. But you should keep in mind that the main window is the renderer process, but we write this code in the main process of Electron. If you want to know more about the Electron JS framework, you can check out a talk that I made, that I did in the Real Talk JavaScript podcast with John Papa and Ward Bell, and where we talked about building secure Electron applications and how we could create an Electron application secure. I have included the link in this slide, so you can check it out if you're curious. Excuse me. So let me tell you a bit history about Map Explorer. Map Explorer was always a part of Plex-Earth, and when I say a part, I mean it had been built inside Plex-Earth. Now, this Map Explorer that you see here, that you saw previously, is not embedded inside Plex-Earth. It is a completely separate application. It is a different executable. So we have Plex-Earth from the one side application and Map Explorer. They are totally different, but they can cooperate. So as I said, Map Explorer had been created inside the Plex-Earth, but we decided to rewrite it from scratch using Angular and Electron and make it a separate desktop application because of three main reasons. The first one was to enable collaboration between different types of users and devices. So suppose that you are a civil engineer that sits in front of your office, as we all do now, and uses AutoCAD to build a house. And you need to import a map from Map Explorer. What would you do? You would open the desktop version of Map Explorer, as we saw in the video, and import a map inside AutoCAD. Now, this map could have been created by an administrator using another version of Map Explorer on the web. For example, a web interface, imagine. A completely different version of the same product. So we would like to enable this type of collaboration. But the second one was that we would like Map Explorer to be serverless. And when I say serverless, I mean we didn't want to use any backend API. The backend API is the Map Explorer itself, because all data of user are kept in the local file system in a JSON format. Okay, so you can understand that the Map Explorer is not, we don't just render a web application inside Electron, we do more than that. We have also a backend API inside it. And the third reason was that this is not so much a reason, but an important consideration that we needed to take care when rebuilding it from scratch. Because you see now, MapExplorer and Plex-Earth are two different applications. So we needed to find a way to communicate each other, one process with another process, because there are different processes. So this was a challenge. And I will show you how we tackled this problem. We created the three approaches, the three prototypes, until we end up with the main product. Let's see the first one. So in the first prototype, we used the Signal-R library, which is a socket-based architecture. I think it is built by Microsoft. Yes, by Microsoft. So Plex-Earth and MapExplorer could connect to a central hub in the web, because Signal-R is deployed in the web, and they can communicate each other by exchanging messages. But this prototype has a main drawback, the latency of Signal-R, because we should think that we are talking right now for two different applications, two different executables in the same machine that they want to communicate. The round trip delay, the round trip delay to send a message and get the response will be very noticeable for the same machine. So we decided to terminate this prototype and we didn't make it. We didn't make it in the final product. Now, in the second prototype, we used a method called ACA. ACA is a toolkit for building distributed peer-to-peer applications. Initially, it was created for Java, but later it was ported to C#. So this made our goal easier. It is based in an actor architecture where you have a parent and some childs that can communicate each other, the parent with the child. So in the Plex-Earth, we used a port of ACA, which is called aka.net, to start the parent process. Now, the real challenge was how to communicate from the parent process of Plex-Earth to MapExplorer, which is a Node.js. It's not .NET, it isn't in C#. So what did we do? We used a library called edge.js. It is a library that is used to run .NET and Node.js code inside the main process. Particularly, we used a library, a port of this library, which is for Electron, called Electron-Edge. This is an NPM library. And MapExplorer called Electron-Edge and executed a C# script called load actor. And this script contained code to initiate a child process. So now we have the parent and the child process in the same language, so they can communicate each other. But this approach had also some drawbacks. The first one was the support of Edge.js was very poor and the documentation was incomplete. But the most main reason that we decided to not go with this approach is that we were forced to use the remote object of Electron to communicate between the main process of Electron and the renderer. So, Aris, what is this remote object? So imagine that the main process can expose global variables in an object called global here. So suppose that the main process can attaches the FS library into this global variable. FS is a Node.js library for interacting with the file system. Now, the renderer can use this remote object, which is a part of the Electron required, to get this global. And from now on, it can use the file system. So wait, Aris, what are you talking? what are you saying? That the render process, which is an index, which is an HTML file, can access my file system? Yes. So is this secure? Is this correct? Of course not. We shouldn't do that at any cost. So what we could do, if you have any Electron application and you want to disable it, you can use the enable remote module for the enable remote module property and set it to false, which is inside the web preferences property of the browser window. So if you set it to false, the renderer cannot access any exposed native object from the main process, and you are safe. At the end of the slides, I have a link, I have some resources, and there is a link that points to a Medium article where it explains why remote is harmful. You can check this out. So, prototype 2, it's over. Let's see the prototype number 3, which it was the prototype that we finally used. What did we do? We used all plain old school files. Yes, files. Okay, I know it's a bit weird, but it works for now. So imagine that Plex-Earth uses the command line to start the executable of Map Explorer, and it passes a file map.json as a command line parameter. The map.json file contains a set of instructions and commands that Map Explorer must execute. After Map Explorer executes the commands, it writes the response to the file system. So then Plex-Earth can read the file system and get the response. For example, the image data, in our case, images. Map Explorer writes images in the file system. But okay, it is a file system, it is not reliable, it is not non-real time, but it works for our case right now. We are currently in the process of evaluating some other techniques, but we haven't found anything yet. So the good thing was that we got rid of the remote object. And how did we do that? We used IPC communication, a method for communicating between the main and the renderer process of Electron asynchronously. So in the main process, we use an object called IPC main, and we use its handle method, which effectively adds an event listener. We pass the name of the event listener, get data, and then an arrow function that will be executed when someone calls this get data listener, this get data event. Now, in the renderer process, we use another similar object called IPC renderer to call, and we use the invoke method of the IPC renderer to call the event that we have registered in the main, passing its name. If we want to pass any arbitrary data, we could use the second method of the second parameter of the invoke method. Now, please notice, sorry about that. Please notice that in the renderer we can use async await syntax, which is very important because we can write more clean code. We will see later how to do this. So when we started, when we started to write, we decided to go with the third approach, obviously. And when we started to write it, we were searching to find if there is any starter guide or any boilerplate that integrates Angular and Electron. But we didn't find anything important except of a repository which was maintained by the Angular team itself called Angular-Electron. There was a great try to create an integration between them, but unfortunately, after some months, they abandoned it. So we decided to create our own custom starter pack. which is what I will show you now because it's time to see some code. So no more slides. Okay. If my screen is, if you cannot see my screen, I will zoom it, but if you cannot, even after zoom, you please tell me. Okay. I think it's okay here. Right. So this is the good stuff. Okay. We have an Angular application, an Angular CLI standard application I have created using ng-new, nothing fancy here. The structure looks familiar, almost. If I run the application using ng-serve, or you know, I'm a fan of Visual Studio Code extensions, and I use this one, NX Console, which has many goodies. I will serve it. Okay, run. This extension is made from narwhal.io, by the way. So the application is built, usual stuff, if you know Angular. Okay, let's open it in the browser. Right. Sorry about that. Let me set up my screen correctly. Okay, so here you can see the layout. It looks like the skeleton application that Angular CLI creates by default, because I used this application. The difference is here we have a list of pirate names. By the way, I decided to use pirate names because of this flag that is behind on me. If you know what this flag is, please let me know later. So here we can see a list of pirate names. Where does they come from? If we open our code and go to the source assets folder, we can see there is a pirates.json file which has the pirates names. So the pirates.json is our backend API in reality. I choose not to use a real backend because I didn't want to. I think we need to focus on this side, on the front-end side. So our application has only one. It is a simple one. It has only one component, app component here. You can see here that we use the ng4 directive to iterate over a property pirates. Now, these property pirates, we have created an Angular service that uses the HTTP client, and it actually calls the get method of the HTTP client in this pirates.json file. Please notice that we don't return an observable, but instead we return a promise, and we use the toPromise method. This is an ArcJS operator that you can use to convert an observable to promise. And why do we do this? Because then in our component we want to use the async await method. So you can see in the ng-on init we call the getPirates method. The getPirates method has the async keyword in front. We have the local pirates property, and then we call the getPirates of the service with the await. So, to be clear, if we open network tools and make a refresh, we can see that it makes a call to the HTTP indeed. So now I will show you how to convert this application this Angular application into a desktop one. And we will not make an HTTP request to get data, but instead we will load data from the local file system, so that to give you an idea of what Map Explorer does. Okay, because Map Explorer does actually this type of integration. It doesn't use HTTP, everything is local. So let's see how we will build this. Let's start from the package.json file. Okay, it's the starting point of every Angular application. So in dev dependencies, we have defined Electron, and we put it inside dev dependencies because Electron is used only to convert to run our application as a desktop one. Not it is not used during runtime. Instead, in the dependencies object, we have defined a package called ngx-electron. This package is a library that provides a wrapper API over the Electron object. Of course, you could create your own wrapper, your own wrapper API. There's nothing to stop you. But in our case, we would like to have something, steady and ready to use. So in the source folder, we have the app folder, which is the folder of the Angular CLI of the Angular application, and we have an Electron folder, which is the folder that contains the source code of the Electron part. So if we open this, we can see a main.ts file. This is the main entry point of our Electron application. It looks like it has the same meaning as the main.ts in the Angular application. So if we open it, we can see that it has a function called createWindow that creates the browser window that we saw earlier. It sets a width and a height, and it also sets another property called node integration to true. This property is needed by the ngx-electron library, and it actually enables Node.js in the renderer process, which is not always good, to be honest. Then, after we have created the main window, we use the method load file, and we pass an index.html file. This index.html is the HTML file of our Angular application. So then we call the createWindow method inside a when-ready promise that is called on the app object. The app object is the actual object, is the actual Electron application, and the window is the, we can say, the website, the web page that loads inside the application. Notice that the app object could have many windows, could have loaded many windows. Okay, so here we say when the application is ready, then create the window. And then on the bottom, we use the IPC main object to create an event listener called getPirates, which it actually reads the pirates.json that we saw earlier from the file system using the fs library, and returns it as a list of strings, as it is the same process that HTTP client does, but this one is reading it from locally from the file system. Excuse me. So let's go back to the package.json file. Here we have some scripts. Actually, we have two pairs. One pair of start script and one pair of build script. Let's see the start script. The start script is when we run ngserve in development mode. It's the same. but there is also the start electron. So let's see what this do. It uses concurrently. Concurrently is an npm package that allows you to run multiple commands concurrently without waiting for the first to finish, and then you don't need to wait for the first for one to finish and to start the other. So we use concurrently to run two processes. We build the Angular application and we build the Electron application. So let's see how we build the Angular application. We use ngbuild, our known ngbuild. We pass a configuration called Electron, which we'll see later. And we also enable the delete output path to false. Why do we do that? Why do we do this? Because at the end, the Electron source and the application source files will be outputted in the same folder, so that the packager that we will use later, which takes all the source files and creates an Electron package, it will be more easier for him to. It will be easier for the packager to do this task. So you only need to remember that the Electron source files and the Angular source files, they go to the same output folder. Now let's see what is this Electron configuration. If we go to the environments folder, we can see the environment.ts and the prod, which are the usual ones, and we also see another one called environment.electron. If we open this environment file, we can see that it has production, the production property, but it also has another property called desktop, which is set to true. So we are actually creating an environment that indicates that we built for a desktop application, not for a web. Because our target and our main outcome of this is to be able to build the same application in web mode, so that you can host it in a web server and as a desktop application. So, how do we this? If we go again to the package, here in the Angular.json file, we use the Electron. We have created an Electron configuration that makes the replacement, the usual replacement of the environment. So if we go back to the package.json, this is the first command that we executed, okay, that builds the Angular source files. Then the other command runs webpack, and it passes a configuration file called webpack.electron.dev.config.js. It's a very long name. And we also execute it in watch mode as the ngbuild. Let's see what is this config. If we go in the file structure on the left-hand side, we can see three webpack configurations. We have two configurations for Electron, one for development and another for production. And we have also a base configuration that is used to the other two. Let's see what this base configuration does. So, initially, we are interested only for TypeScript and JavaScript extensions. I have also added here JavaScript, even I don't have any JavaScript code in the Electron side, because if you want to clone the repository or get the code, you may use it with JavaScript. So we set the entry point for the Webpack to be the source folder, which is the source Electron. And in particularly the main.ts file that we saw earlier. We use tsloader npm package to transpile main.ts into JavaScript. And we also pass a tsconfig for the transpilation. We also use two plugins, the no emit on errors plugin, which it actually says that if you have any errors during building, do not continue. and the progress plugin that displays the progress of building. We have a node object that contains two properties, fs and dir name. These properties indicate the Node.js APIs that we use in our Electron source files. So we have put fs and dir name because we use it inside our main.ts. If you use another Node.js API, for example, crypto, you should put it here. Sorry. And then we set the object target to electron-main to indicate that we build for the main process of Electron. Because do not forget that the Angular source files are the renderer in our case, and the Electron is the main. Okay. If we now go to the dev configuration, we can show that it extends, it uses base config, but it also sets mode to development. It sets source map so that we can apply debugging techniques and add breakpoints to our application, and it outputs the main.ts, the result of transpiling the main.ts into the dist folder Angular Electron sample, which is the same folder that we will also output Angular application. But please notice that the file name that we use is self.js. Why do we do this? Because when we run in development, when we run Angular in development mode, it creates its own main.js. So we don't want to interfere each other and create a conflict. So in the package.json, we have our script that starts the Electron application. But how our application does the real magic? I mean, how does it know when to what to do when it calls start and what to do when it calls start Electron? Let's see. In the source app folder, which is the Angular application, we have created an Angular service called Pirate Local Service. This service has the same signature as our Pirate service that we saw earlier with the HTTP client. The main difference is that it does not inject HTTP client, but it injects a service called Electron service, which is exposed from the NGX Electron library. It also has a getPirates method, the same signature as previously, but instead of calling HTTP, it gets the IPC renderer property of Electron service and invokes the event listener that we have registered in the main process, getPirates. Okay. Please notice also that I didn't need to change anything in the component. The component works as is. That is why I used async await here, so that I don't need to make any modification to the component. And how does our application knows which Angular service to use? If we go to the app module, we can see the great benefit that the Angular dependency injection mechanism gives for us. We have used the provide object literal in the providers array, and we say that when someone requests for the Pirate service, use the factory, the Pirate factory, and let this factory to decide what to create. The Pirate factory injects both HTTP client and Electron service. And according to the value of the desktop property of the environment that we saw before, if this is false, then it creates an instance of the Pirate service. It passes the HTTP dependency. Otherwise, if it is desktop, it creates a Pirate local service and passes the Electron dependency. So let's run it to see how it works. if we go to the npm scripts here, this is built in the Visual Studio Code, so you can run it without opening a terminal. And click on Start Electron. So it starts building. It built the Electron application, and now this here is the Angular application. Okay, so they both run in watch mode. So if I change something in the Angular source code or the Electron source code, they will compile again automatically. To run now the application, I have created inside the .vs code a launch.json script. This script will be executed if I go here and click debugging, start debugging. What it does, it uses the runtime, the Electron executable, and especially this one because I am in Windows. It tells which program to debug, which TypeScript, and which is the output file of the main.ts. And it also enables the source maps so that I can put a breakpoint inside my Electron code, not Angular, Electron. So if I press run, okay, here it is. I hope you can see it. Let me zoom it. I think it's a zoom. No. Zoom in. Okay. So it is the same application as before, but you can see here it is rendered in an application. Sorry. What's that here? It is rendered inside a desktop window. Now this window, the page inside the window is Chromium. For example, it has developer tools. I can open them and I can inspect my application. It has a console. I can do any stuff that I want, that I can do with Google Chrome. I can do this also. So let's check if our getPirates method works correctly. So if I go to network, and make a reload of my page, I don't see any pirates.json HTTP call. Why? Because the data come directly from the Node from Electron, which is the Node.js API, the Node.js runtime. So there is no HTTP call. So we run the application. Okay, should we run it also for production? Because when we create a web application, we finally want to make it production ready. So let's see how we do this. Let's go back again to the package.json. And let's see the second pair of scripts, build and build Electron. Now build is the usual ng build. And build Electron, again, builds the two applications, the Angular and the Electron, together. But it doesn't do it concurrently. I mean, we don't want to have them both running at the same time. We build them one by the other, and whenever they finish. So first, we call ng-build with the Electron configuration again, and we pass some production options of the Angular CLI to make it a production build. These switches, these parameters, are the same as those that are used by the Angular CLI when you do ng-build -prod. And then in the Electron side, we call Webpack, but we pass the prod config.js configuration this time. Let's see what it contains. Now this one, it also uses the base config, but the mode is now production. We don't have source maps, obviously, and this time the output file name is main.js. Why? Because when we build the Angular application, the Angular CLI will put a hash number in front of the main JS file of Angular. So there is no way that they can interfere with each other. Also, we use a plugin called Copy Webpack plugin to copy the package.json that we have inside source electron. Here, inside source electron, except of main TS, we have the TS config, which is used for transpiling, and a package.json. Now, this one has some properties of the author or the package, for example, the name, the version, and it also indicates which is the main file, which is the main.js. There is also a case that you may have your own packages. For example, if in your Angular, in your Electron code, you use an npm package, you should put it here, and you should write dependencies and list it, just like an ordinary package.json. Okay. So the webpack prod config will take this package.json and copy it to the destination folder, to the dist folder. Also, we set a property called externals, which calls a method called node externals. What this does, if in your package.json you have some dependencies, as I said before, essentially, by calling node externals, we are telling to Webpack that, Mr. Webpack, I don't want to bundle all my dependencies inside the main.js of Electron, but instead, I will later npm install them, and I will bundle the node modules folder together. If you have any questions about that, you can ask me right at the end, because it's a bit complicated. So, let's run this npm script. Build Electron. You can see here it starts building. Okay, it built the Angular application, and now it built also the Electron application. So if we go to the dist folder, let me delete this. Okay, let's see the dist folder at the end. Okay, so we built the production version of our application. Now it's the time to bundle it. We have two different versions of our application, web and desktop, but we want to bundle the desktop one as an Electron application. So how do we do this? Let's go again to the package.json file. Right, in the dev dependencies property, we have defined a library called electron-packager. This library bundles your application and for the three main operating systems, Linux, Mac OS, and Windows. There is a ton of options that this library has. For example, you can only build for one platform if you don't want all of them, or you can even build for Windows platform from Mac or from Linux. There are so many options that you can choose. Now, this Electron packager is used here in a script called package. This script calls Electron packager. It passes the source. It passes the source, the path that of the source files, which is our dist folder. It defines the output folder using the --out switch. And it also passes a property called ASAR. ASAR is a zip format for Electron applications. Actually, it is a zip file. For example, you can open it. It has an extension .asar, and you can open it and see the code. I mean, it's very simple. If you don't use it, your bundle will contain the dist folder as is, as we see it now. If you pass an ASAR, it will zip all of the source, all of your dist folder into an ASAR file. We will see this later. Also, we have a script pre-packaged that will be called before the package script. Now, what does it do? It changes the directory to the dist folder, and it executes an npm install over the package.json file of Electron. So if you have some dependencies in your Electron application, it will read the package.json file that has been copied from the copy webpack plugin, and will create the node modules folder for these dependencies. There is no harm that the bundle file will have the node modules folder. It's okay. I mean, many applications do this. If you see Visual Studio Code, it has node modules folder inside its bundle, so there's no problem. So let's run it. Package, npm scripts, package. Okay, here you can see that it's packaging the application for Win32 platform, because I'm in Windows machine. So if I go to the dist folder now and open it, okay, here I can see there is a folder with the name of the platform that I choose to build. Inside here, sorry about the icons. We can see here that it has an executable application. This is our exe. So if you see the size of this executable, it's 105 megabytes. Now, our code is not contained in this executable. This executable contains Node.js, Chromium, and stuff from the Electron side. Our code is inside the resources folder, and it is this file app.asar, which is only 189 kilobytes. So we bundled an Angular application of 189 kilobytes into an Electron application of 100 megabytes. Okay, that's not so great, but you know, we have to start from somewhere. So if I open it, you can see that it works as before. Let's continue with the presentation. Now, in the last slide, I have some contact information about me and some resources that you can check out. That was all that I would like to share with you. I think that I will make you to be more curious about Electron and desktop applications in the context of Angular. And I have also here the URL of the demo, which is at GitHub. I will put the slides in a bit later after we finish, and I will share it with you. So that was it. Thanks very much. And I'm available for any questions that you may have.
Okay, so if you have any question,
continue one here. Can anyone hear me? Okay, my name is Samuel. Okay, I have a bit of experience with both Angular and Electron, and my question to you would be, how are you able to integrate the Electron with Angular? I've seen like Webpack files, and when I tried it myself, it didn't like have that much of a setup. And did you use something like a CLI? Yeah, or how did you, yeah, how were you able to like fully integrate it? And I saw so many files. Yeah, that was my concern. Yeah, because all I thought was you just like do an npm install Electron, and yeah, from there it just bundles into the Angular app. But I see you've done it a bit differently, and it worked for your side. I
Yeah.
hope you are able to get my question.
Yeah, I understood it. As I said at the start, we were searching for a boilerplate to make the integration as smooth as possible, but we didn't find something that would satisfy us. There is an open source library which is called, I think it's a boilerplate, a starter pack, which is called Angular-Electron that you can use. But we decided to create our custom boilerplate because back then because this application is about 4 years old now, there was not something out there in the open source community that would be okay for us, for our case. I know that there are a lot of files, but you see, when you create something by your own, you are more flexible. I mean, if you have a problem with the Webpack configuration, you can fix it yourself. You just don't wait for someone to create a pull request or create your own pull request and accept it. But if you want some more less code, you can use the Angular-Electron. It's on the GitHub. It's a very good starter pack. I believe that I answered your question.
Yeah, you've answered my question. Thank you. And if there's no problem, I have another question.
Sure.
Why didn't you like just use Electron Forge? What was the main decision between integrating Electron with Angular? Why didn't you just like go with Electron and use CLI like Electron Forge to just make the desktop application?
Yeah, good question. Most of the applications out there, I mean Visual Studio Code, Slack, Skype, they write the user interface inside the Electron. But we decided to write it using the Angular CLI because our expertise was in Angular. We are Angular developers mostly. So we wanted to leverage our existing skills of Angular and bring it together with the Electron. Of course, we could have used a library for Electron that creates the user interface, and we could have written the user interface inside Electron. No problem with that. Is this okay?
Yeah, thank you.
My pleasure.
So I had a question. You said our application could have many windows. So how do you go about creating the multiple windows?
No, I haven't used any. Our application is a single window, so I haven't used with multiple windows.
I was asking, so how do you go about creating the multiple windows?
Oh, okay, sorry. I don't know exactly. I haven't used it, but I have seen other applications that they can do it. I mean, there is also a library. You can find it on their website, on the Electron website, that allows you to create also separate tabs, which is very nice, like Google Chrome does.
Okay.
Okay, maybe if I could like just help a bit on that with the a bit knowledge I was able to gather on the issue of creating like multiple windows. Okay, well, as I am still learning Electron, you can just like create instances of the browser window, and you just create a global shortcut and include it in your main menu. Then you'll be able to create instances of windows and tabs. Yeah.
Right. Now that you said about the menu, in the application that I just showed to you, would you like to share up my screen now again? Okay, hold on.
Yeah, it's fine.
Is it? Okay, here you can see that it has a menu. This menu is built in from the browser window. You can change it. It has an API. It has an Electron API that you can put your own menu. And there is a property called is packaged on the app object that tells you if your application runs in packaged mode or not. So what you actually can do is check this flag, the is packaged flag, and if it's true, so you are in a package mode, you can create your own menu. So you show a different menu when developing rather when deploying. That's it.
Okay. Well, any other question? So if there are no more questions, I think we'll come to the end of the meeting. Thank you, Aris, for the wonderful session. I've learned a lot, especially
My pleasure. It was my pleasure to be here. I wish I could go to Kenya, but you know, I can't right now. But sometime in the future, I wish I can do that. And I am very grateful that I meet you all.
Yeah, you're welcome. We say Karibu. You're welcome. Okay, so thank you for the wonderful session, Aris. And I think we'll come to the end of today's session. Yeah. Well, thank you. Thank you all for attending today's session. And
Thank you.
have
Bye.
a lovely...
Yeah. Sorry, guys, I'm dropping in like last minute. I was on transit, so few things. Thank you, Aris, once again. I know and she's taking it to a close. On behalf of Ivy and also the whole of the Angular Kenya team, I'd like to say a big thank you and taking us to the session. I was really glad when I was walking people asking questions, which was really good. And that meant that people were actually understanding or following through the... Again. Yeah, back to you, Ivy, as you close the session. Oh, and the session is being recorded, so we are going to have the recording up on our YouTube channel for anyone else who probably would want to refer back to the session or share with friends. Yeah, thank you.
Thank you.
Okay, thank you, Geko. So we'll come to the end of the session. So thank you, guys, and bye.
Bye.
Love
Take
you.
care.
Bye.